Today we're going to be looking at our geometry 1 through 15 test review. Okay, and the first question that you're going to get, it's going to give you a graph, and it's going to show you the endpoint. So let's say that we had an endpoint here, and an endpoint all the way up here. One of the things that they're not going to tell you is they're not going to tell you what the coordinates of those two endpoints are. So if we had something along the lines of, there's 1, here's 2, here's 1, here's 1, and let's say that that's 2. What I would have to do with this, because what the question is what is the midpoint? So if I was making a list of skills I need to have or formulas I need to know for this test, the first formula or the first thing I need to know is I need to know the midpoint formula. Okay? The first thing I'm going to do with this question is I'm going to state the coordinates. In this case, it's -2, +1, and then we have 1, -2. Okay? Does that make sense so far? Those red coordinates are not going to be given to you. You're going to have to look at the graph. So you need to, one, a lot of students have trouble determining x values and y values of coordinates. X values are left and right, y values are up and down. I know that seems, for some of you, that seems really elementary, and that's great. I hope it is really elementary, but for some students, they get them flip-flopped, okay? So just so we're clear, x, y, and for sake of our formula, we'll call this x1, y1, x2, y2. All right, as a refresher, what is our midpoint formula, Allison? X1, you said minus? X1 minus Y1? No. But it does tell us one thing, is that we're getting this confused with probably either distance formula or point or slope formula, right? Should be x1 what? Plus divided by 2, and then over here, okay? In our geometry, there's a lot of different formulas that we have to know, and it's really easy to get them mixed up with one another and create some different formula that isn't going to do what we want it to do. All right, what is x1? Okay, -2 plus what? Divided by 2, and then over here, y1 is 1 plus divided by 2. Okay, -2 plus 1? -1 divided by 2, okay? And then we have 1 plus -2. -1 divided by 2. So the midpoint is -1/2 and -1/2. We could kind of be able to go up here. Obviously, it's a hand-drawn graph, so it's probably not going to look incredibly accurate, but we would go -1/2 to the left and -1/2 down. It should be about there. Obviously, probably this 1 coordinate there, that -1 coordinate, all that needs to move down a little bit. This is why we do things on graph paper instead of trying to hand draw our graphs, because we're not going to put our tick marks perfectly spaced. Okay, does that make sense? All right, so our answer is here. Again, this is not the question on the test, but it shows you all the same skills that you're going to need to have. Does that make sense? Okay. All right, this next one is tricky. Okay, they're going to tell you that B is the midpoint of AC. Okay? They're going to tell you that A is, and it's going to have coordinates. Somebody give me a set of coordinates. 3, 1. Okay, A is 3, 1. And B. Somebody give me coordinates for B. Anything. 1, 3. Okay. 1, 3. Okay. Find C. Okay. Find C coordinates. The mistake that people make with this question, does anybody know what mistake might be made here? Tiffany? Right, they're going to find the midpoint of A and B instead of AC. B is the midpoint of AC. So let's write up our, and this is all the question is. Okay, so what I'm going to draw in red here is what we're working through. So first off, let's start by writing that midpoint formula again. What was it? Okay. Now in this next part, we're going to fill in. Now, what is the coordinates for A? What could I label 3? X1 and Y1. Now, is B, is this X2, Y2 over here? No. In fact, really what we want for C is X2, Y2. All right? If anything, what we're saying is that this is X3, Y3. Okay, that's the solution. So let's go ahead with what we have and fill in. X1 is what? 3. 3 plus X2, right? Divided by 2 equals what? What does it equal? Yeah, and what is the midpoint? What's the X midpoint value? 1. Okay, now let's come over here. What's Y1? 1 plus, no, Y2 divided by 2 equals, okay, we're solving for X2, Y2. Okay, this is a question that trips up a ton of kids because it gave us the midpoint and we have to find what the coordinates, what the other half of the coordinates are. How do I solve for X2? Multiply both sides by 2. All right, so we have 3 plus X2 equals 2. Okay, that crosses that out. What's next? Subtract 3. Subtract 3. What does X2 equal? -1. So the X coordinate for the other side is -1. Let's come over here. How do I do this over here? How do I solve for Y2? Multiply by 2. Multiply by 2. I have 1 plus Y2 equals 6. No?
Do you have anything you can recycle?
No, not that I know of. Okay. All right, what do I do with the 1? How do I move it over? Subtract. Subtract it over. So Y2 equals what? 5. Okay, so the coordinates for C are -1, 5. And we can test this answer. Okay? 3 plus -1 is what? 2. 2 divided by 2 is 1. Okay? 1 plus 5 is 6 divided by 2 is 3. Okay? So we should be able to test our answer. All right, do we know what skills we need there? So midpoint formula is pretty big so far on this. All right. Number three. Number three is going to talk about a swimming pool. It's going to give you two parallel lines that look like this. It's going to give you a transversal somewhat like this. Let's see. Let's say call that 6x plus 8 degrees. And 8x minus 12 degrees. Okay? So I'm gonna basically, rather than try to write it down, okay? So this is one where you're going to go back and listen to the video because I'm going to tell you what the question is asking. It says, in a swimming pool, two lanes represented by lanes L and M. Okay, where this is L and this is M. Okay, let's call this transversal T. Okay. If a string of flags strung across the lanes is represented by that transversal T, and X equals, let's see, I don't know, might be able to say X equals 10. I don't know if that works or not. We'll have to see. We want to show that these lanes are parallel. Okay? All right. So in order to show that the lanes are parallel, what do I have to do with the X value? Substitute it in. So I would be writing 6 times 10 plus 8. Let's actually do. I don't know. I don't know that X, because I'm just testing stuff out here. So we'll see if it works. Okay. So we got 68, right? And then we have 8 times 10 minus 12. 8 times 10 is 80. 80 minus 12 is 80 minus 12. Is it 68? All right, great, works. All right, so basically what we're saying is that when we plug in 10, we get 68 here and 68 here. Okay, can anybody explain to me how that proves that those lines L and M are parallel? What are these angles right here? All right, so by the what property? What property are we going to use? Because I'm guaranteeing you it'll have two that are identical. Okay? Well, maybe they aren't. Okay? These are alternate interior or exterior? Interior. All right. Derek, what's the difference between interior and exterior? Don't know. All right. The difference is in relation to the parallel lines. Okay? This area out here is exterior. Okay? The area in here is interior. Okay? Inside. Does that help? Okay? So alternate interior angles are congruent. So what we would use, so our therefore is by the converse of the alternate interior angles postulate lines L and M are parallel. Does that make sense? A little bit, hopefully, maybe. All right. Let's see. Number 4. You're going to need to classify a triangle by its sides and angles. Okay? Sides, angles. All right, how can I classify a triangle by its sides? What are the terms for classifying a triangle by its sides? Okay, isosceles, scalene. Okay, right is not a definition for by its sides. Equilateral. Okay, how do we classify a triangle by its angles? Obtuse, acute, and right. Okay, so whenever I'm looking at angles, how do I know if a triangle is obtuse? One angle is greater than 90 degrees, right? What about acute? All angles less than 90, right? And right?
One angle 90 degrees.
All right, so we'll say one angle, okay, is equal to 90 degrees, right? So that one there refers to one angle. All right, isosceles. What does isosceles refer to? Two sides congruent. Scalene. All sides are different lengths, so 0 sides congruent and equilateral, or I'll say 3 sides. Okay, so I'm not going to show you what kind of triangle they're going to give you. You just need to know that you're going to get a triangle, and it could be isosceles right, could be isosceles, I'm guessing you might be able to get isosceles acute or isosceles even obtuse. Scalene, equilateral, okay? You want to look at those things, make sure that you know what they look like. Okay? All right, this one, they want a counterexample for. So we want to find and this is something that we've struggled with, is understanding counterexamples. All right. So we need a counterexample where C equals something and D equals something. Now, it's got to meet what? What part of it has to be true? No, opposite. Meaning, so his statement was, the part that has to be true is C over D has to be greater than 0. No. but we're identifying it now, okay, so that we don't make that mistake tomorrow. What has to be true is that C has to be greater than D, okay? What cannot be true for this to be a counterexample is C over D cannot be greater than 0, okay? All right, so what's an option here? C greater than D. What's that? What you're going to get is you're going to get numbers that are going to go in for C and D. So let's say, for instance, all right, so let's say we said C equals 10. What would be true of D? So it has to be something that's less than 10, right? But whenever I divide it, I get something that's less than 0. Something smaller than 10, but whenever I divide 10 by it, I get something smaller than 0. What's smaller than 0? A negative value, right? So is a negative value going to be less than 10? Okay, if I divide 10 by a negative number, am I going to get a negative number? All right, so give me a negative number. Negative 5? Okay, is 10 greater than negative 5? Yeah. Is 10 divided by negative 5 greater than 0? Yes or no? No. So is it a counterexample? Yes. Okay. So we're looking for a value for C that's greater than the value of D, but whenever I plug them in over here, I get an untrue statement. That's what we're looking for. Okay, does that make sense? All right. You can understand now why whenever you go back to watch a video like this, you need to listen to it. Okay? Let's see. They're going to give you two figures. Okay. This should be like the easiest question on the test. Okay. We want to determine the missing measure in the set of congruent polygons. Determine all right. What's the missing measure? 11. Right? And they're going to have units next to it. So let's say for a second that this is inches. We would say 11 inches is our answer. Okay? There's no even real work to show for it. So if you got the right answer, you're just going to write that in a box. Okay? That should be a freebie. Okay. All right. On this one, you need to be able to find a midpoint on a number line. They're going to say on a number line, x is at negative 13 and z is at 11. What is the midpoint of x, z? A lot of midpoint stuff on this test. How do I go about it? Draw it out, okay? Okay, I got a line. What, 0? How far to the left am I going to count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How far to the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you got a point here. You got a point there. Now what? Add them together. So 13 plus negative, or negative 13 plus 11. Is that what you're saying? Absolute value, very good. Absolute value, negative 13, close, not quite, minus 11. Okay? Yep. What are we going to do with that value? Okay? Negative 13 minus 11, what is that? Negative 24. Okay? What's the absolute value of negative 24? 24. Does that work? Divide by 2. So it would be, so you're dividing that by 2 and you're getting what? 12? Couldn't be 12. 12 would be over here, right? How can that be the midpoint? Negative 24 would be your, or, so the halfway point between negative 13 and 11 is a value clear off over here. How do you find the midpoint on a number line? Did we do something wrong? 11 minus negative 13. It's going to be positive 24. What's that? Say that a little louder. Add them and divide by 2. Okay. So let's see. 11 plus negative 13. What's 11 plus negative 13? Would that be what? Negative 2? Okay. And what, you want to divide that by 2? All right. Which is going to give you what? Negative 1? But the absolute value is 1. All right. So let's look at this. So the distance from 13, okay, we understand that the distance is 24, right? All right. Half the distance is 12, correct? So if I count to 12, right, I'm going to wind up at negative 1, correct? If I count from here to 12, there's 11, 12, okay? So do I need the absolute value? No, I don't need the absolute value. We're taking negative 13, or it's really technically, I guess, absolute value of negative 13 minus 11. Okay, it's giving you that 24 divided by 2, right? It's giving us an absolute value distance of 12. But then I have to either add that to negative 13 or subtract that from 11 to find out what that location is going to be. Does that make sense? Okay, so we can test it through the number line and see where it's going to be. Okay, just kind of common sense wise. Okay, to test our math. Does that make sense? So then we're going to do, here we're doing 11 minus 12 equals negative 1, or negative 13 plus 12 equals negative 1. Negative 1 is my answer. Okay? Because we're adding 12 over here, subtracting 12 from over there. All right. 8. All right. Here, let's All right. Which angles, pairs of angles, if they are congruent, prove that lines L and M are parallel? They're going to give you a bunch of different pairs. Okay? You have to go back to that lesson 12 and be able to understand really 4 different categories. Okay, those 4 different categories are corresponding angles, alternate interior angles, and really just alternate exterior. So because we're talking about just being congruent. Okay? Those are the 3 categories that if angles that fit those 3 categories are congruent, then it proves that the 2 lines cut by a transversal are parallel. Can anybody identify any corresponding angles? Okay, angle 2 and angle 5, very good. 1 and 7. What else? 3 and 8? No. Oh, 4 and 8. Yes. 3 and 6. Now I noticed that once one person says, like 2 and 5, suddenly we know what the other 3 are, right? Okay, you need to be able to know what corresponding angles are on your own, okay, without somebody kind of giving you that first heads up. All right, alternate interior angles. We've already kind of looked at this. All right, what angles are alternate interior angles? 3 and 7. Okay, what else? 5 and 4. Now, I'm going to tell you on the test, they're going to give you something like 2 and 4, which is going to confuse some people because they know that angles 2 and 4 are vertical angles, and vertical angles are congruent. That's all right, thank you. But that doesn't prove that lines L and M are parallel. Does that make sense? Okay. There's only 2 sets of alternate interior angles. What about alternate exterior? 1 and, no, not 1 and 8. 2 and 8. Remember the alternate part. 2 and 8. 1 and 6. Okay? Now, those are just numbers. They may not put them in the same order. The 2 parallel lines with the transversals not going to be oriented the same way. So no matter how those parallel lines present themselves, how that transversal line shows up, You need to be able to identify these 3 sets of categories. Does that make sense? Okay? Because they're going to give you 4 different options. Only one of them is going to fit, and it may not be a corresponding angle. It may be alternate interior or an alternate exterior. Okay, but you need to know, what do corresponding angles look like? What do alternate interior angles look like? What do alternate exterior angles look like? Okay? Number 9. Okay. Let's see. Number 9 is going to be based off of this question here. So let me see if I'm going to steal this for a second. Okay. We're going to say if, let's see, let's call this L and M again. If L and M are parallel, okay, and measure angle, what do they use? What are they looking for? Okay, let's say okay, measure angle 1 equals 65 degrees. What is measure angle 5? Angle 1 is 65 degrees. What is that guy right there? How do we find out? Perfect. You can solve for measure angle 2. What do we know about angle 2 and angle 5? They're corresponding angles, and if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. All right, so solve for angle 2. How do you solve for angle 2? All right, Tiffany identified that angle 1 and angle 2 are supplementary or linear pairs, meaning that angle 1 plus angle 2 adds up to equal 180. So if we subtract 65 from 180, we'll find angle 2, and because angle 2 and angle 5 are corresponding, they'll have the same angle measure, correct? All right, so 180 minus 65, what is that? 115. Okay, so angle 5, therefore, is 115. Okay, does that make sense? Okay. Let's see, what are we ready for now? 10? This should be easy. What is the area of a triangle? Somebody give me a number. With a base of 5, somebody give me another number, and a height of 10. So I need to know the area of a triangle formula. What's the area of a triangle formula? Base times height divided by 2. What's the base? 5. What's the height? 10. It's 5 times 10. 50 divided by 2. 25. And in this question, it'll be feet squared. Easy? To me, this feels like an easy test so far. All right, that's the first 10 questions. I'm going to stop here for now. Hope to cover the next 10 questions later today. Send the entire document and both videos to you, okay? You'll probably get a total of 4 videos. You'll get videos made for your class and 7th hour, but you'll also get last year's videos as well, because I have them, and why not give you as much as I possibly can, okay? Test tomorrow. Should be ready for it. All right, we'll stop there.